Learning Center. I'm here with Dr. Sand, and he's going to teach us about some kinetics today.
Hello everybody, I'm Dr. Sand, and today we're going to be talking about kinetics. Let's just start out by saying what kinetics is. Kinetics is the study of the rates of chemical reactions where they can occur at many different rates over a period of time, of a fraction of a second to days or even years. There are many variables that can be controlled in order to speed or slow down a reaction. Reactions can happen in any daily life activity, for example, when you're cooking something, or for another example, like the Coke and Mentos reaction. That's a pretty fast reaction. And another fast reaction is explosions. And chemical reactions can be measured after the loss of a reactant or the development of a product during a period of time.
Hi everybody, my name is Dr. Witch, and I'll be talking to you about the factors that affect the rate of reaction. The rate of a chemical reaction is equal to the number of effective reactant collisions in a certain amount of time. There are several factors that affect the rate of a chemical reaction. The first is temperature. Raising the temperature speeds up a reaction because it creates more movement, which would lead to more collisions between particles. Temperature is directly proportional to the average kinetic energy of a sample of matter. The higher the temperature is, the lower the reaction rate is as well. The second factor of reaction rate is concentration. A concentration of a solution is a measure of the amount of solute that is dissolved in a given solvent. A dilute solution is one that contains a low concentration of a solute. Concentrated solution contains a high concentration of solute. The higher the concentration of a substance is, the more the particles will form. The third factor of reaction rate is surface area. A chemical reaction occurs at the surface. If there is more surface area, a reaction could occur faster. If you crush a solid substance into smaller pieces, then when you dissolve it in a liquid substance, the reaction will occur quicker because it increases the surface area of the particles exposed to the liquid. A powdered substance will have the largest surface area and will have the fastest reaction rate.
The fourth factor is identity. The higher the activity of an element, the lower the reaction rate will be. The element that has the highest activity is lithium, while the lowest is gold. The fifth factor is agitation. Agitation or stirring increases the movement of the particles in the chemical reactions, which leads to a lower reaction rate. The sixth factor is a catalyst. A catalyst is also called an enzyme. It's a substance that increases the rate of a reaction. It does this by creating a new physical pathway through a reaction. This lowers the activation energy in a reaction, which leads to more reactants forming. Wait, Dr. Witch, do you know anything about the order of reaction?
Well, yes, Dr. Sand, I do. Changing the concentration of substances taking part in a reaction usually changes the rate of reaction. A rate equation shows this effect mathematically. Orders of reaction are a part of the rate thing. Do you know anything about the rate law?
Well, of course I do. The rate law, or the rate equation for a chemical reaction, is an equation that links the reaction rate with the concentration or pressures of the reactants and constant parameters. Normally, rate coefficients and partial reaction orders.
But don't forget about instantaneous rate, and that's the average reaction rate that is calculated and is useful for obtaining information about the overall reaction. However, at times, you might also need to know about a reaction at a specific time, which means plotting concentration versus time and determining the slope of the tangent to the curve at a given time.
For a zero-order reaction, as shown in the following figure, the plot of concentration A versus time is a straight line with k equals negative slope of the line. Other graphs are curved for a zero order of reaction. For a first order reaction, as shown in the following figure, the plot of the logarithm of concentration A versus time is a straight line with k equals negative slope of the line. Other graphs are curved for a first order reaction. For a second order reaction, as shown in the following figure, the plot of
1 over concentration A versus time is a straight line with K equals slope of the line. Other graphs are curved for a second order reaction.